Hi everyone, myself and Arun Kumar from SNS College of Technology in the Department of ECE. In this video, I am going to share about PD controllers in linear control systems. The PD controllers means proportional derivative controllers or programmable derivative controllers. So let me see how this programmable derivative controller has been utilized for time response analysis. So these are all the slides we are going to see in this video. Understanding the basic elements, so introduction part. So generally the programmable derivative control has been used for a lot of applications, especially it must meet the overshoot process and persistent oscillation and sluggish system reactions. So these are all the constraints need to be satisfied with the help of this programmable derivative controller. Let me see the 6-axis encouraging robot. So it is having a 6-axis technique, so that it will be able to communicate the users based on the errors and overshoot and the controllers of the oscillations based on the report definitions. So the concern framing of the PD controller has been defined with the help of this definition part, especially for the users need the proportional control that minimize the error without instability. It is also concentrated for human-centered design for robotics techniques, because whenever the problems arises based on the stability problem, so it may be defined with the help of the stability problem, and most probably it will be considered comes under the proportional controller, so that it will be eliminated based on the stability problems. And next one is exploring the PD controllers. After defining the problem statement of the concern devices, then it can be explored based on the programmable derivative controllers. It has been executed based on the MATLAB technique, as well as the techniques such as Nicholas chart, because so that we can able to analyze the particular solutions based on these plots on graphs. And moreover, it is also done with the help of the simulation softwares like MATLAB techniques and Simulink process. It will be very useful to know the concept of the exploring techniques. And next one is prototyping. So those techniques has to be a module, and it can be programmable by using the MATLAB software. Then the process are also defined by using the Simulink technique, so that the graph shows that the process from source to destination has to be done by using the Simulink process, so that every plot has to be identified by using the Simulink process in order to avoid the problems of the concern model. Next one is testing technique. So this technique will be based on the different problems and their solutions. If the solutions meet the same errors, mean we need to check the testing process by using the different process. So such as steady state error and robustness against the disturbance errors, and overshoot errors and response time errors. So these are all the errors must be identified by using the testing technique, so that it will be able to communicate to the users without any distortions and without any problems of the stability of the concerned systems. Real world applications. So this PD controller especially used for sensor processing techniques, such as wearable EMG sensor. So EMG means hemographic sensor. It will be identify the corresponding pulses of the arms, so that it will communicate to the users based on the expectation of their output. And next one is mind mapping technique. So the mind mapping is the tool which is used to know about a particular process or a particular solution of the controllers. Activity. So the activity given here is in a DC motor speed control system using a proportional derivative controller, students should analyze how the controller improve the system performance. So take a 5 minutes to think individually, then discuss with your partner. And most probably you can consider the stability and dynamic performance, because the stability and dynamic are the very essential tool for the stability of the concern solution of the problems. And next one is assessment. Okay, the assessment is past question become in a DC motor speed control system using a PD control in automation. Drivers from the ABB, the derivative terms mainly helps to increase the steady state error, reduce the overshoot, and improve the stability, remove the proportional gain, and eliminate the feedback signal. The answer is reduce the overshoot and improve the stability. The overshoot means to avoid the higher level error analysis. So next one is industrial automation system developed by Siemens. A PD controller improves the system performance by responding to only the reference input, only the planned output, present error and rate of change of error, disturbance signals only. The answer is C, present error and rate of changes of error, because while analyzing the PD controller, it must be analyzed at the present state of the errors and most probably the output of the errors. So these are all the reference I have taken for this video. Thank you.